Hi, my name is Sherline Reinaldi, and I am a third-year student in Institut Teknologi Bandung. Today, I will be presenting my study titled Demand Forecasting Using Winters and SARIMA Methods in a Local Theme Park in Purwakarta, Indonesia, with the guidance of my co-author, Desi Anisia Farmasiawati. Let me provide a brief overview of this study. This study will cover the following sections. First, the introduction. In this part, I will provide the background of the research and explain the objectives we aim to achieve. Second is the methodology. Here, I will discuss the research design, the software tools we used, and the formulas applied in the forecasting process. Next is the results and analysis, where in this section, I will explain the process of generating the forecast and present the results of our analysis. Lastly is the conclusion, where I summarize the findings, highlight the key recommendations, and conclude the study. So, moving on to the introduction of the study, our research focuses on PT Cagar Alam Cikao, which is a local theme park located in Purwakarta City, Indonesia, currently one of the biggest local theme park in the region with multiple facilities like water park and mini zoo. So, to provide some context, based on the publishing statistical data in Indonesia, BPS, the tourism sector contributed 4.01% of the GDP in the first semester of 2024. However, this fell short of its target of 4.5%. This highlights the importance of better planning and decision making in the tourism industry. One critical tool for effective planning is demand forecasting, which is essential for most business decisions as supported by the research from Song, Wit, and Lee in 2008. The objectives of this study is to conduct a comparison of forecasting methods that are reliable to be applied, then to generate a 12-month forecast from July 2024 to June 2025 with a suitable model. In this study, we employed a structured methodology to address the research problem. We utilized Microsoft Excel for data collection, Winters model, and forecasting error measurement, while Minitab version 21.1 was used for advanced analysis such as seasonal decomposition, ARIMA, SARIMA, and the preparation methods for ARIMA. As it can be seen from the research design, the research process involved defining the problem, collecting and analyzing data, applying Winters and SARIMA models, and measure forecasting errors using MAD, MSD, and MAPE. Then after measuring the errors, we then know the best model to be used for the data so we can generate the forecast for 12 months in the future. And lastly, we summarize the findings and give recommendations. In the research design that we have just seen, the first step is for data collection. In this study, the source of data collection was secondary data, collected from the company reports in the form of an Excel file, which is the table over here, covering only 31 observations. Next, seasonal decomposition was used to identify the characteristic of the data. There are two methods for seasonal decomposition, namely the multiplicative and the additive methods. The formulas are listed as below. And with this method, the seasonal indices can be analyzed and we can see whether the data has seasonality or a trend. Next, after knowing the characteristics, we can apply Winters model using Excel software because with this software, we can use Excel Solver to generate the alpha, beta, and gamma automatically. We use two methods, also multiplicative and additive methods. Still in the methodology sections, we have the formula for ARIMA model, which is used for time series data that has seasonality, trend, or both, and combines the AR model and moving average model that are integrated, noted as ARIMA PDQ, where P is for the autoregressive part, D for the number of differencing to make the data stationary, and Q for the moving average part. Next, to prepare for ARIMA, we have to stabilize the variance with Box-Cox transformation, stated in this formula. Then, if needed, for data with seasonality, SARIMA, which is an extension of ARIMA with seasonality, can be used. Next, still to prepare for ARIMA, ACF and PACF graphs have to be analyzed in order to find out the order of the moving average and autoregressive. The spikes at each lag determine whether they are significant, and a significant spike will extend beyond the significance limits, which indicates that the correlation for that lag doesn't equal 0. The number of significant correlations indicates the order of the moving average term, and these are the formulas for the limits and the t-statistics for both functions. Lastly, the probability plot of residuals can be used to compare the normality of the SARIMA result used in the comparison of the model accuracy. A larger p-value is better, and a small p-value less than 0.05 means that the residuals are not normally distributed. Next, these are the formulas of the measurement of errors that in this study we'll be using MAD, MSD, and MAPE for the measurement of errors. To the next section, results and analysis, we will cover these steps, starting with data cleaning. That in this process, data cleaning involves filling out the missing values, as some calculations will result in an error when the data value is 0. So next is the seasonal decomposition. It is observed from the seasonal indices that the model assumes seasonality with quite a strong pattern, where certain months like months 1, 4, and 12 showed much higher than average number of visitors, and some months like 8, 9, and 11 showed a low number of visitors. The result of both methods of decomposition suggested that the data has trend and seasonality. Therefore, the proper models to be used for analysis will be Winter's model and SARIMA model. Moving on to Winter's model, as seasonality was observed, the author generated a fit model using Winter's multiplicative and additive models. The graph is the fit of the Winter's model, where the blue lines show the original values and the red lines are the forecast. The solver was set to minimize the MAPE, as the study was aiming to compare the accuracy of the model, and the result is listed as below. With this information, the measurement of error can later be compared with SARIMA result. So, with SARIMA model, to prepare the data, first, a boxcox was applied to the original data to stabilize the variance. The result of the transformation is then stored for a potential second transformation. The rounded value can indicate the lack of need for transformation, and the first graph in figure 6 shows that the rounded value is not 1. Therefore, another transformation is needed to be conducted. After applying another boxcox plot of the transformed data, the rounded value is 1, which means the data now has constant variance and is already behaving well without needing further transformation. After making sure that variance is constant, ACF and PACF graphs need to be generated to analyze if the data is already stationary and to find out the order of AR and MA. Here, the ACF graph with 5% significance limits for the autocorrelation shows that the first lag is the only significant spike, followed by insignificant lags that oscillate. The ACF behavior strongly points to an MA process, and the negative first spike indicates that the time series is influenced by a moving average model of order 1. So with this information, the author tested out the models and made this comparison of significance. From the graph, it can be deduced that the models that all components are significant are the SARIMA 001101 and SARIMA 001001. So with this information, the residuals from both models were plotted and had the p-values compared. If we compare figure 10 and figure 11, we can see that the figure 10 has a better normality distribution, and the p-value of figure 10 is also higher than the figure 11. So we can conclude that the model SARIMA 001101 has a better accuracy compared to the other model. So with this final comparison, the accuracy of each forecast within the period is compared by their measurement of errors. It can be seen that Winter's multiplicative model has the lowest MAD, SARIMA 001001 has the lowest MSD, and SARIMA 101 has the lowest MAPE. However, in terms of overall accuracy, SARIMA 001101 is the best choice because it achieves the lowest MAPE and has reasonably low MAD and MSD compared to other models. Therefore, it can be concluded that this model is the most suitable model to forecast the number of main entrance tickets using the data from January 2022 to June 2024. Then this is the result of the forecast with the red line as the forecast and the blue line as the original data. With the result, we can conclude that the data has a trend and seasonality with high peaks in months 1, 4, and 12, making Winter's method and SARIMA model suitable to be conducted for comparison on the data. Then we found out that SARIMA 001101 was the most suitable for predicting the total number of visitors to PT Cagar Alam Cikao, with no reservation upon the visit based on the data from January 2022 to July 2024. And the forecast indicated that the highest peaks would be in August 2024, December 2024, and January 2025, followed by April 2025 and May 2025, with the lowest number of visitors forecasted would be in March 2025. So another recommendation for this study is that there will still need further works to be done with more observations in the upcoming year, and the company also have to update its forecast, preferably every month. And judgmental forecasting is still important for the forecasting method, and it can be used as an adjustment after the data has been forecasted. So these are the references that were used in this study. Thank you.